Good evening. Thanks so much for joining the Research Triangle PowerShell user group. We're super excited to have Fernando Tomlinson join us. He's going to talk to us about using PowerShell in the offensive and defensive modes. And so take it away, Fernando.
Hey, good evening, everyone. Thanks for having me here. Really humbled and grateful to be here tonight. So this is my talk. We're talking about living off the land, defensive and offensive PowerShell. I'm an avid PowerSheller, just like everybody online. A little bit about myself. I've been with the Department of Defense for about 19 years. I currently do forensics and malware analysis for United States Army Cyber Command. Previous to that, I was leading the Security Operations Center. Previous to that, doing some incident response of sorts. I'm a cybersecurity adjunct professor where I teach Python digital forensics, and starting next semester, I'll be teaching a PowerShell course that I developed this semester. So super excited about that, to take the love of PowerShell and put it in academia for people who are aspiring to learn more about it. I like to develop blue and red team tools, all in PowerShell, and really a number of different languages. I'm a co-author of the PowerShell Conference Book Volume 2, along with a number of people who are joining us tonight. So definitely support that, support Volume 3 as well. We don't make any proceeds from the sales of the book. Those are underrepresented, underprivileged individuals trying to get their start in cybersecurity through a number of methods and means. I developed a number of interactive PowerShell training platforms. As you see there, I'll talk about both of those rather quickly once we get to the near of the presentation and kind of walk through those real live demo of sorts. And if you're looking to connect with me outside of this presentation, that's my presence, if you will, on the interwebs. Okay, so very quickly, there's our agenda. We got a lot of things that we're going to try to pack in here, but we're going to get through it. All right, so about PowerShell. You guys already know, guys and gals, 2006 is when it came on the scene, implemented as an engine, right? So when we think of PowerShell.exe and PowerShell_ISC.exe, that isn't PowerShell. That's just a hosting engine that allows us to really have access to that DLL system.management.automation.dll, which is really the true PowerShell juice, if you will. PowerShell is an interactive command shell, so that allows us to utilize the ability to go interactive and interact with the system itself. It's a scripting language. It's very object-oriented of sorts. So we have properties and methods associated with them. We have the ability to do some remote management. And you probably heard Mike or a number of other people talk about that, right? So allowing us to really interact with one-to-one machine or one-to-many machines of sorts. And it's built on top of the .NET framework. So what does that mean? That really gives us access to a lot of the .NET classes to really make PowerShell a lot more extensible than what it may already be. A number of the functionalities are built through commandless functions and scripts. And guess what? We can also use those native commands. Those are things that you already know, right? But what are the real true advantages? Well, if I'm a blue team person, if I jump on a Windows 7 2008 R2 system and above, PowerShell is already there. Granted, it's largely going to be PowerShell v2, but that's not important right now. The important fact is I have PowerShell there, and I can leverage the system, or really PowerShell, to interact with APIs on Windows. I have the ability to encrypt my traffic. So if I'm trying to reach out and interact with other machines, I can make sure I'm getting some integrity, if you will, from that CIA model, confidentiality, integrity, availability. I can get some integrity with that communication of sorts. I have some logging and controls that I can do, a lot more than other scripting engines. Now, that's going to vary based upon version of PowerShell, of course. And I have the ability to do some monitoring and some detection, if you will. And I don't necessarily have to install an agent, be it an open source agent or something that my organization may be paying for. I got a number of things that I can use already built in to the platform. That's great, cool. So now I'm going to take my blue team hat off, and then we'll put on the red team hat. Well, what makes it great from a red team perspective? You'll see some duplications here. The fact that it's already installed on those versions that we mentioned makes it great. I don't know about you, but when I go over to a get-together and I ask people, what do I need to bring? And they say, Nando, don't bring anything, just show up to the party. That's what's happening from a red team perspective. They're able to leverage PowerShell on the system, and they can use it to bend it for their will without having to bring some other form of malware or malicious toolkit with them. Because we can utilize that language from a red team perspective, we also can utilize those APIs. So same APIs that provide information for us from a blue team perspective give very relevant information to a person with malicious intent. And guess what? No red team guy or malicious actor wants to be having their traffic in the clear. So the same way that we can encrypt it from a blue team perspective, we can do that here. Now, depending on the version of PowerShell and really the way in which we use it, we could avoid and bypass detection mechanisms. That's super great. AMSI and a number of other things kind of make it a little bit difficult, but guess what? Where there's a will, there's a way, right? So we can continuously kind of do a cat and mouse thing, if you will. Luckily for us, if we're a red team person, some people don't understand the importance of PowerShell and therefore do not update their version of PowerShell. They have whatever is standard based upon that operating system. And if they're using some legacy infrastructure, let's say Windows 7, we may get lucky and get on a system that has version 2. And as you know, version 2 has little to no security features built in. If they do have it upgraded or they're using a more modern version of Windows, they're typically not optimizing their configuration of sorts, turning things on like transcription login or what have you. And guess what? We can inject our code in memory and execute it from there. And what does that allow us to do? Well, that essentially allows us to not have to have something on disk that, depending on the AV, would scan and trigger for malware. So we're now running in such a space that's a little bit more abstract and allow us to be a little bit more stealthy in some of the things that we do. And really, the last one is a close number one for me and what makes this great. And the fact that it's script-based attacks, it largely makes signaturing difficult. Like, there's been a number of times I've seen specific code be triggered as malware. And then when you dig into the AV as to why, it's specific comments or specific commandlets in which they use or a succession of things. And I'm like, wow, good on you for catching this very generic thing that we pulled down and used. But understanding that it takes little to no effort to reshape what I'm doing and make things a little bit different, especially when we start talking about a number of obfuscation tactics and techniques. All right, so looking at the landscape, right? Because we all really know that it's a great sysadmin tool, right? A number of people are doing amazing things in this field as far as automating tasks, right? Automate the boring stuff. If I got to do it more than once, I'm automating it. Yes, cool. And in some respect, we realize that malicious people or red teamers are utilizing it as well, and we recognize why. We also recognize that blue team members are using it as well. I think the big thing to take away here is that it isn't these 10 or so reasons why an admin used it versus these 10 or so reasons why a red team person used it. There's some duplication and tripling, if you will, of reasons across the landscape. So there's a lot of duplication and tripling of sorts, but we see that there's a little bit of something special for all three entities, if you will. And when I say three entities, it doesn't really stop there, right? Because for anybody who's online right now who has a Tesla, let me just make it known real quick. Nando does not have a Tesla, right? Let you know where I'm at on the pay scale, if you will. But for anybody on the line who has a Tesla, there's a module that somebody developed so you can control your Tesla. OMG, this is awesome. Or maybe it's not awesome. Depends on what hat you have on right now of sorts. But the fact that somebody utilized PowerShell to develop this module speaks to the modularity of sorts in which this language allows you to become, right? The extensibility of sorts. And if you think I'm joking about it, no, you can Google it. Somebody's got it out there of sorts, right? So enough about that. Let's talk about some of the blue team stuff, right? And when we go into this, this isn't going to be a full extensive list. This is just a couple of things. And building this talk was really difficult for me. Why? Because there's like 5 million different blue team uses of PowerShell. So I had to nudge it down to a couple of sorts, right? So really when we look at it, as a blue team person, I want to be able to hash files and items on a disk, right? Why? Because I may have an indicator of compromise, be it a hash or in some case an IP or something else. And if I get matches of that, then I'm rest assured, or I have high confidence that a system is compromised or malicious based upon possibly that indicator of compromise. So we have an input. In this case, we're going to use the binary command.exe. We have a hashing algorithm or a function of sorts. And from that, we get a one-way computation. We get algorithms such as MD5, SHA-1, SHA-256, right? And each one of those has a varying length based upon the algorithm of what is returned. So on the left, we're using MD5. On the right, we're using SHA-1. So from a PowerShell perspective, we have get file hash. You may already be familiar with it. We can specify an individual file, and then it returns the SHA-256 of that file. We could also feed it the algorithm in which we want to use for a function. Doesn't necessarily have to be SHA-256. As you see, we've done MD5. And then if we wanted to, we got a number of different ways to do a directory of sorts of files, right? This is good because if I'm at a point where I wanted to, I don't know, hash every file on my system, I could do that with PowerShell. That's going to be costly in the sense of processor and intensive on the system, excuse me. So what I recommend instead is checking out something like the National Software Reference Library. Once a quarter, they publish a list of quote unquote well-known hashes for Windows systems and then common software that we may find on them. And what we can do is we can take a targeted approach in hashing certain files on our system, validate them against this known good list, and then continue on. If that's not the approach you want to use, well, you could also use something like VirusTotal, right? And from a VirusTotal perspective, we have the ability to do 4 hashes per minute utilizing their free API. And we got about 5,700 that we can do in a day. This is going to check about 50 antivirus solutions. Now, the key here is with the free API, we got 4 in a minute, so we need to be cognizant of that. And I don't want to be doing something like SVC host every couple of minutes, because once I've done it once and validated that the hash was good on VirusTotal, I can then start to make my own list, my own array, my own dictionary, whatever you want to go with, to then have my stuff validated against it. And again, going off of not hashing the whole disk, I could do something a little bit more targeted. Let's say I just want to do running processes. Well, in about 10 or so lines of code, we can get a list of those processes. We can loop through them. We could hash them. And then anything that we don't have access to because it's protected, we could just spit that out to a file. And again, I would only want to do that one time for the thing that I've seen the first time. And then the next time I see that binary, I want to check to see if it's in my list already, i.e. did I already look this up? And if so, I want to get the reputation there. I only want to reserve going out to VirusTotal for the stuff that's brand new. And this is how I can be smart about the 4 that I can submit per minute, especially if I'm trying to do this in a centralized manner across some type of environment, if you will. So utilizing this code, invoke VT hash search, is going to allow you to run or submit these hashes to VirusTotal. It's automatically filtered in for it to do 4 a minute. So in this case, we submitted 2, and it's going to tell me my estimated runtime is 30 seconds because it factors in submitting 1 every 15 seconds. We see varying lengths in my hashes because I'm highlighting that it doesn't necessarily have to be MD5s or SHA-256. It could be any mixture of them. Now, when this data comes back, it comes to me in a list, right? And this is where it comes into what does an analyst like? Some analysts like to do analysis on their data in the form of a list, while that doesn't necessarily work for other people. So I like to flip mine to a table. And when we do that, we see the AV name up front. Second column is going to show us the version of that AV. Third column is going to show us if it was false or true. If it's true, that's a trigger. And if it's true, the fifth column is going to show us what does that antivirus know it as. The next column is going to show us the date of the signature, if you will, and then it's going to show us the hash associated with it. So if I'm scanning a file or a hash rather, because we're not uploading this to VirusTotal, we're just searching for the hash. If I'm searching for the hash and out of 50 AVs, none of them tell me that it's malicious, well, right now I'd say I'd probably trust that and keep going because I'm looking for the low-hanging fruit. But depending on my environment and who may be targeting that, that doesn't necessarily mean that I'm necessarily out the clear. If I get a couple that start to trigger, well, those are going to be the things that I start to focus on first. And if I get something that triggers like all 50 or close to 50, of course, that's going to grab my attention of sorts, right?
So, Fernando,
yeah,
yes.
There's a question in the chat that's really relevant to what you're talking about now. A couple of people were asking, like, we understand the concept of building a hash list and using that instead of going out. How long would you rely on that list before maybe you generate a new list or age out the old ones?
Well, that's a good question. I think it's going to be architecture dependent. For me, for the architecture or environment which I work in, if it's deemed good now and it's something that is a well-known hash, like let's say SBC host or LSAS, something like that, that's not going to change, I'm probably not going to go back out and never do that. But if it's a one-off binary based upon some type of program that somebody may be running or a PD executable, well, then I might go back out there and check that somewhat often because that could absolutely change. So I think it's going to be environment dependent based upon the environment in which you're in. But yeah, some you might not ever go back, right? Like SBC host isn't going to change. And if it does, it's because Microsoft got compromised and we got a bigger problem.
So in that same fashion is if you're, from a sysadmin perspective, the idea is that the same hash is going to be SVC host's hash is going to be the same across all of my systems. So I only really effectively need to build that hash across my environment effectively, and then these are the files. So even like the Windows system files, they would be the same across the environment, and then these files would be the same. But then my custom apps and stuff like that, those I could still have a centralized like list of all of my hashes.
Absolutely. Right.
So even if they're multiple machines, it'll be the same.
Can I ask a question real quick? So this is really cool with PowerShell, but how is this different than AppLocker with Windows?
Well, so AppLocker, well, now we're talking like whitelisting and blacklisting, right? So I'm not tracking AppLocker actually goes out and does some validation to say whether this is malicious or not. Here we're doing almost real-time analysis to say it's malicious. If you're actually executing whitelisting or blacklisting, you're much more better postured, in my opinion, than what we're doing here. Some environments take the time to do that because that's a little bit more intensive, in my opinion, from the very beginning. Like you pay a lot man hours up front, but you reap the benefit later on, while other environments don't. My environment does not.
10-4.
Cool.
Okay, good questions. I don't see the questions list, so if they come up again, please somebody stop me.
Yeah, don't worry. We'll take care of that, Nando.
Okay. All right, so the next thing, right, from a blue team perspective, processes, net stat, if you will. I mean, common. What's running on the box? What type of connections do we have? What binaries have a port that they're bound to? And when I look at this, individually, this is good, right? So I look at my process list, I'm getting stuff of interest. I might transition over to my network list, and I might return in my network list binaries that are tied to a established connection or have a port open. But when I look at it, there's an actual PID associated with it. And now when I transition back over to my process list, sometimes I might be like, what was that PID? Was it 1, 2, 3, 4? Was it 3, 2, 1? I get a little mixed up, if you will. So I find myself transitioning back and forth and really we want to take some of that human nature ability out of it where somebody could mess up, if you will. And then I had this epiphany. Well, started thinking about Reese's Pieces and a Reese's Cup and when they put it together, how it was pure magic. And if I had more time, I would have had confetti drop out the ceiling or something right now. I thought that was a genius thing. So guess what we did? We just put it together and then we made our own object, right? So we want to reduce some human oversight. We want to provide a clearer picture for analysis for the analyst, and then it's easily exportable to CSV, XML, JSON, whatever you want. And what's key about that? Well, you could import it into your SIEM or your log aggregation system, or however you want to continue to conduct analysis on it. So getting that data back, we have two different entries, if you will. We see very clearly the local and remote IP import for each one. We also see very clearly the name, the PID, the process path. We see the hash associated with it and any command line argument. And guess what else we see? We see what kicked it off, right? What's the parent PID, and then the same stuff associated with it. So in one view, we start to get all that information as opposed to having the swivel chair back and forth and try to put it back together. All right, so automated profiler. I recall a couple of years ago where I was on this very highly visible incident, and we had found something, and my supervisor was standing over me and my team, and he's like, okay, where's the report? Where's the analysis, right? Because it had some high visibility. It wanted to be able to provide that to some higher leadership. And I don't know about you, but anytime I have somebody standing over me, like, is it done yet? Is it done yet? Is it done yet? I can't concentrate. If I can't concentrate, I can't get the job done. So I didn't want to feel like that anymore, neither myself or my team. So we ended up coming up with automated profiler. And roughly it takes about 4 minutes, depending on the system and what resources are available, for us to parse a 500 gig hard drive. Now, what does this really do? Well, this is going to go through, for anybody who's a forensic analyst, and it's going to provide the information that you would always look for and include. This is going to be able to provide you more time to do deep dive analysis. People always want an initial report of sorts. So we're getting the key stuff, right? Things that have downloaded, some execution, USB history, USN journal, right? MFT. Now we're talking about essentially table of contents, if you will, for a disk image, any keyword searches of sorts. So you're able to buy yourself more time really up front. You're going to mount the disk, right? FTK, in case whatever it is that you're using. Then you're going to run the script. You'll be able to analyze it, you'll be able to relax, or continue on to go a little bit deeper on the disk. And really that's going to come back to you in a flat text perspective, formatted rather decently considering what we're working with. But again, in a couple of minutes, being able to parse a disk image, looking for the things that we always look for, utilizing PowerShell, so we can then focus our efforts on the deep dive analysis of sorts. Automated profile.
Hey, Fernando, we had a question about the get verbose process that wanted to know how it differed from sysmon logging, or is it similar in terms of output?
So I think it varies a little bit, but let's talk about the sysmon logging. When I was doing incident response, right? Let's say I'm coming to your organization. I'm like, hi, I'm Nando. This is my team. We're doing incident response in response to whatever is happening. To do this, we want to deploy sysmon. We want to deploy this EDR. We want to change this setting, and then we want to be able to get this data to respond to your intrusion. Depending on the environment, you might be like, hey, my house is on fire, but no, you're not doing that because it's got to go through change management. No, you're not installing that because we don't understand what it is, right? So when we get into that type of conversation, then this is where verbose process gives you that ability very quickly. And really, we talk from a defense perspective. If I had the ability to install sysmon, or sysmon was all over the place, it'd be a different conversation of sorts. But now if I'm looking at it from a red team perspective, although I probably wouldn't use this from a red team perspective, again, it's already there. But largely speaking, if it's do I use verbose process or sysmon? Well, if you got sysmon available, you're going to get the enrichedness that you're probably already seeking to get. Okay, awesome. So now when I look at the DNS process, right, we're going to explain this DNS process, kind of some so what behind it. So let's say a user navigates out to google.com. Well, first thing the system's going to do is check his local host file, see if there's any entry in there for google.com. If not, it's going to check the local DNS cache, see if it already has the IP for it. If not, it's going to query whatever is configured for its DNS server. And if that DNS server has it in its cache, it's going to provide the answer back. If it doesn't, it's going to see if it's the authoritative source for that domain. And if not, it's then either going to utilize root hints to go get that answer, or it's going to send it to a forwarder depending on how it's configured. Now, if I'm at a point where there's an intrusion in my network, and if we look at the incident response model, I'm trying to contain it, I may look to sinkhole the domain or prevent the domain from being resolved. And I got a couple of places in which I can affect that. Well, if it's 1 or 2 systems or less than 10 or less than whatever you're willing to go touch, if you will, or script out, I can utilize the local host file. I can put an entry in there for Google, and I can put the loopback IP or quad zeros. If I'm talking about a full environment, well, I'm probably going to look to do that at my DNS server, the lowest one of sorts, and just make myself authoritative for that domain, and then give it quad zeros or loopback. But when I say sinkhole, what am I talking about? Well, let's say nandynan.com is known to be malicious. I want to prevent my users from getting it, and we've already seen 2 places in which we would do that. Let's take this picture. Let's use a car. The car would be on my left and would be trying to get on the other side where those buildings are at. There's a gigantic sinkhole there, which in theory is preventing me from getting to my destination. So essentially, when I sinkhole that domain, I'm going to prevent the machine from getting the information it needs to then navigate to that domain. Now, the person, the malware, is using IP addresses, game over. It's a different tactic that I would need to get at. So develop the script, invoke sinkhole domain, and very simple, straightforward. We're going to execute it. We can then download a list of blacklisted domains from a reputable site, or we can feed it a list of domains that we just want to block. It's going to create a forward lookup zone for those domains, create A records pointing at quad zeros or quad A records for IPv6, right? And when we see it, when we look at that lookup zone, we see all those domains, essentially those records in which we are now becoming authoritative for. So now when the system tries to navigate out to that domain, we're going to feed it back quad zeros. It's not going to be able to resolve it. We're starting to contain this in my environment. Now, I would also look to do it from a network perspective, and we've all heard of defense in depth, right? So if I've done it from a network perspective where I'm dropping any DNS requests or any packets associated with the IP of that domain, if I'm dropping that, and I'm also dropping essentially the DNS perspective, I feel rest assured that I'm doing a decent job at trying to contain whatever this threat is that I'm trying to prevent. All right, so looking at event logs, you already know 2 different ways to look at it. We have our classic log way. We have our get when event where we're going to do classic logs and event tracing of sorts. And really what we're trying to get to with event logs is they provide a wealth of knowledge and information. But when we just call upon it straight out, gives us this table view, and this isn't very useful. 4688 as an event log ID is probably one of the best event IDs that Windows has available, but unfortunately isn't enabled by default. But nonetheless, from this view, I get that essentially there were 20 instances of this event ID being triggered, but I don't really get the guts of what's going on. Now, when I look at it and I expand that, I see these properties, but really what I'm looking for is in the message field. Particularly, I'm looking for something like the account name, maybe the process name, maybe the creator process command line, and every event ID might be slightly different. Luckily for me, there's properties within the properties that I can then dial into to be able to call upon them. Because right now, if I just called upon message, I would essentially be looking at the contents of that essentially as a string. But when I can utilize the properties of the properties, I can essentially take those sub-properties and call upon them specifically and start to reshape my object and or make my own. So when I do this, now I can see this in a much clearer picture. I can also do much more streamlined filtering for what it is I need. And in some cases, I might find something that I would have not purposely, but accidentally overlooked prior to that. In this case, I see netcat running and I see it going out to an IP address on quad 4s, right? Quad 4 is typically associated with Metasploit. Okay, awesome. So I'm starting to find things that I may possibly would have missed otherwise. And then I can utilize out grid view if that's my thing, or I can just pipe that data back into my seam so I can then do some enriched analysis of it. But garbage out, right, is going to be garbage back in. So I need to be able to filter that data specifically what I need. Again, going back to that thing of when I come to your environment, I may want to install an agent. Well, developed a EDR, if you will, in PowerShell. Now, the unfortunate thing about this is with an agent, the agent utilizes a push method where as stuff happens on the endpoint, the agent pushes it back to the server. So you get much more near real-time analysis. Utilizing the method in which I've done it in PowerShell, we're doing a pull method where on some pre-described time on our server, we're going out to the endpoints and pulling that information. What's the so what of that? Well, the so what is we may miss some information based upon us utilizing this pull method. So it's not near real time, it's just really based upon how often we do it of sorts. But we get some enterprise-wide visibility, quick identification of anomalies, and this is modular in nature. So there's about 20 items of interest that we already pull, but you're more than willing to create more modules and incorporate it in there. The data comes back in CSVs, but also in a SQL database, so you can look historically as to what you previously have gotten, and it utilizes a network logon. So if you're concerned with throwing credentials all over your environment and people using a malicious tool like Mimikatz, well, the network logon isn't susceptible to Mimikatz. And when we look at some of the items that we retrieve, well, these are a number of things that from a incident response perspective or just a analysis perspective, things that we would want to go after and look at, right? And again, it's modular in nature, so you can add more to the framework and continue to build it out if you so choose. All right, so we're going to take a second here and we're going to actually execute this. Heck, I don't even know what it's called. Okay, sorry. All right, there we go. So execute PowerShell 2. I can either pull stuff from the domain listed based upon the domain in which this computer is already in, and I can just pull it out of AD. I can import the computers or IPs from a file. I can input a computer or IP manually, or I can just run it against them. So what we'll do is we'll come in, and I'm going to do number 3. I'm going to input a system, and I can feed it a single IP, or I can do a CIDR notation of sorts, so I can give it a subnet. So we'll do 172.168.155.200. And now it's going to go through, and essentially, if I had more than one machine, it would be multi-threaded, where it's going to go out there and task those machines to then execute this code, which then renders that data, and it's going to bring it back and consolidate it of sorts. So we'll get the data, we'll do some consolidation, we'll do some shifting of the data in the background on the server so we can keep most of the resources that are being used on the server and not inflict that on the endpoint. And that's going to be in the sense of consolidating the CSVs, writing that stuff to our SQL database of sorts for us to be able to use it. Now, we'll come out here and we'll go look at this data as it comes back. And for each instance or iteration in which we've ran PowerShell 2, that data is going to come back in a folder of that date and time. Right, so we see we're running it right now. My clock's at 2:07, and that data is slowly but surely coming back. Now we're running it on one machine, so it looks to wait for 10 machines to come back before it starts to consolidate. So it does it in 10 machine chunks. So it's trying to give it a second to see if there's anything else before it starts to do its consolidation, and we see that it's already going. Now the database is a SQL database. You see it's already at 9,000 kilobytes because we're cumulatively just adding stuff to it. And I can use something like SQLite and just read that database. And actually, we're going to go ahead and stop it from adding to it. But we see that it's at the point where it's adding now. And I'm going to go ahead and stop it so I can import this database in so we could look at what it kind of looks like. And when we look at having a database, this is going to give us the greatest ability of granularity, right? So we could have this hooked up to some other front end that we have. We can hook it up to whatever it is that we want, or we could just use those CSVs right out the gate. We don't necessarily need to use this database, but this is going to come back in a number of formats in which should make it easier for you, the analyst, to be able to analyze and conduct analysis. And that's really what we wanted to be able to incorporate here, is granularity of sorts of what we can do to be able to really find malicious actors. And we don't necessarily have to have an EDR or go through change management to get something added to a domain. Although, commercial EDRs and some other open source ones provide great capabilities, and I'm no way, shape, or form saying we don't need them. But I'm just really highlighting that if we don't have those type of things available, we're not dead in the water, that we can absolutely meet the intent of what our job is. And we're doing it all in PowerShell, something that's already there. Okay, so when I'm looking at doing some malware analysis, all too often, malware seeks to inject itself into critical processes, right? So let's say I had PowerShell running and somebody had injected a malicious portable executable file into my PowerShell process. Okay, well, cool. I'll just terminate that process, and that will terminate that binary from running. Sounds like an easy one. What happens when somebody injects malicious content into, I don't know, a critical service like LSAS, like Explorer? We're not just going to go in there and start terminating that. And guess what? Malware authors realize that, so they want to get into those critical processes. Well, invoke suspend process allows us to suspend the process and essentially tend to the maliciousness that's injected into a profile without terminating the process itself. So when we look at like ransomware, that gives us the ability to try to go after ransomware keys of sorts, so we're not always having to go and pay a ransom. We're also not breaking critical services from within a Windows machine because we're able to suspend that process. So we'll come in and we'll run this.
So kind of for those who aren't too familiar, so the idea of suspending a process is then you can then access the memory of the existing process and do other things with it. So you don't necessarily want to kill the process, you want to inspect the process and do other things with it. A running process, correct?
Correct, right? Because if I terminate the process, if it's a critical service, I'm going to have other implications on the box. If I just leave it running, well, it's still actively terrorizing my machine or doing whatever its beck and call is. So I want to suspend it so I don't terminate the process, but I don't actually still have the malware running. And then I can actually do some form of interrogation of sorts, right? And actually tear it apart. We also find where software or malicious content will create a process, hollow the process, start another process, and then put that executable in the hollowed process and terminate the previous. This is all as a form to further hide themselves. And when they terminate the previous one, we lose a lot of artifacts. But if we can catch it in such a place where we're able to suspend the process, we can then make a memory dump or capture memory of that process and then be able to analyze it with whatever your favorite memory analysis tool is, be it volatility or something else. So off to the top left here, I have a binary that literally just spits out an integer and says it's beaconing home, but it really doesn't do anything. It just spits it back out to the screen.
So when you're doing some of this analysis too, is there some like certain processes that you'd be cautious with doing this on? So like LSAS and stuff like that, it's like, can that even be paused?
So depending on the rights that you have. So in my current rights system, I'm sorry, as administrator, no. I would need to elevate to system to be able to affect LSAS. But if I wanted to terminate Explorer, absolutely, I could terminate that right now. Or I could affect it and pause it, if you will.
Cool, thanks.
No worries. So we have this demo binary running. I'm going to get the PID. That's going to be 8096. And then we're going to come in here and we're going to suspend it. We're going to feed it the ID. And now we see that our iterations have stopped. The process is still running. It's just in a suspended state because we've added a debugger. Now I can go in here. I can create a copy of that process, dump the memory. I can do some analysis. I can do some live analysis on it, or I can just pause it so it doesn't actually continue to do its malicious intent while I try to figure out what to do next of sorts, right? This is really geared towards doing some forensics, malware analysis, if you will, from a PowerShell perspective. Now, when I'm ready to continue on, because I've gotten it to a point where I'm just ready, I can then go in there and resume this, right? So we got two functions here, and I'm gonna feed it the process ID again. And when we start that, then it just continues to run. Again, I need to be able to have rights to it. Some protected processes require I have system, so I would need to elevate to system level rights to be able to affect those services, if you will. And then there's a number of other ones I can do with my elevated rights on a system.
Hey, Nando, why
Yes.
don't we pause for 2 seconds there? Because I have a feeling if we paused, people would probably ask some questions. There's been a few things in the chat which we could pass along. But guys,
Okay.
if you have a few questions or you want to pass them along or jump on mic, you can. I saw someone wanted to know about how does LSAS react to being paused?
Oh, it's going to jack up the system, right? So LSAS was a bad example. LSAS is a really bad example. It's going to jack up, right? But taking LSAS out of it, if there's other services of sorts or processes that we can't terminate for one reason or another, then we could suspend it. Yeah, but LSAS was a bad example.
Okay, so guys, why don't we take a 2-minute breather here? I'm sure you kept up with everything Nando's covered, right? It's all just very basic knowledge that everybody's absorbed already, right? I'm kidding. If you have questions, please, we encourage you to ask them. So if you want to throw them in chat, we'd be happy to try to get to them. Nando can't see the chat right now, so if you want to jump on mic and just ask you a question, feel free. And just know, if you're wondering, like, is my question appropriate? It is, unless you're doing the voice recordings that Rahi Gandhar was doing earlier. But we want everybody to have a chance to chime in. So we're going to let him go in a few minutes because he's going to go and he's got more to do. But if you have questions about what we've done so far, try to get him in now. Anybody?
Yeah, this is Mark.
Hey, Mark.
The question I had was, when you're reading the master file table on a 500 gigabyte drive, how much memory do you usually expect to need on that?
I mean, the systems that we've run it on is anywhere from 4 to 8 gigs from an endpoint perspective. I haven't witnessed where there were where it became so resource intensive in which I couldn't do it of sorts. And this is a dead box analysis, if you will. So this drive's slave to whatever my forensics machine is. But I haven't witnessed it being so intensive where I couldn't utilize it. Because it's actually just pulling the MFT file itself. It's not trying to assemble some other variation of the MFT.
Right, I understand. But on my laptop, I found that yeah, my memory footprint while I was reading the MFT into PowerShell, it really ballooned. So, and I don't have nearly that much on my laptop. And I was thinking, oh my gosh, if you got a 500 gig drive with that's similarly packed, how big is that master file table?
Yeah, I think it depends. Depends on the system. Depends on the system in which you're doing analysis. But I would definitely love if you got some time to run automated profiler on your box and we can do some comparison based upon your machine. Absolutely, that'd be worthwhile.
So Mark, question for you. Are you running that against your own live machine? Because one of the caveats he said is this is a drive that's been slaved into a forensics machine. So it's like
Right.
scanning the D drive.
Right. That is the difference, that I was running that on my own system.
Ah, okay. Yeah. Then Mike, good catch. Yeah, this is essentially the box over here is malicious, or I'm not malicious, has some suspicious stuff on it. We've unplugged it, turned it off, took this drive out, put it in a write blocker, hooked it up to my forensics machine, and yeah, it appears as if it's an external drive at that point.
So
Got-
with that too, now I'm gonna go to the next question. Just like all the tools that you've talked about so far are all in your GitHub repo, or are they also somewhere else, or is there for all them?
Nope, they're on my GitHub, and I'm not going to come on here and talk about anything I wouldn't give you guys, right? Because that's just teasing, if you will.
No,
So, yeah,
it's like
they're
is
on
that
my
central
GitHub.
repository? So yeah, so that's the go-to place. It'll be updated, and as things get updated, that's where to go. Perfect.
So Fernando, I had a question from way back when you were looking at the processes stuff.
Okay.
That looked like something that would be really useful to watch more in real time. Do you usually like set up like a scheduled task for that, or do you have like a watcher service that's executing that to watch processes as they get built up?
I don't. I think that's a great idea. If I'm focused on one machine or even my own machine, generally I'm trying to do it across a subset of systems of sorts, and I haven't ran across the initial use case to do it, but absolutely, I think that would be super great to have it just watching as things pop up and bam, some little window in the bottom right of sorts. Sounds like I got a fork coming from you later on and on GitHub, so we can make that happen.
Sounds good. All right. Any more questions before we keep going? All right.
I told you guys, this is the real deal here, man. This is this is a fire hose coming at you.
Yeah, I'm very passionate about the subject, and I would definitely go. All right, so I apologize there. Definitely, if you got questions, stop me, and I will pause for the cause.
Okay. Question. A little while earlier, in an earlier slide, you talked about the process being a pull process as opposed to a push process, and I was wondering if callbacks could be used to get closer to that push that push time scale, rather than relying on periodic pulls.
Yeah, absolutely. And for that, now I got to think about some type of agent-based thing on the endpoint where as things happen, the endpoint calls back to the server with that information. That could easily be another script of sorts that serves that. The quicker thing for the use case that I had was I stand up the server. I have an account that's associated with my actions. We monitor for the actions of that account on our scene, providing Overwatch, and then we utilize network logon to go to the machines and pull. And then when I'm done in your environment, the cleanup is removal of my account. You continue to monitor in your scene for usage of the account, which nobody should be using at that point. When I look at possibly doing it from an endpoint solution, pushing to the server, we're just going to have to extend that code and touch more machines. But yeah, absolutely, we could look at that. And it's a give and take there, right? Because largely speaking, we absolutely want a push method so we can have something near real time. Yeah, so good comment. Thank you.
And you might want to show people how to enable the 4688 on the machines.
I think there's just documentation for that. It's basically enabling process creation and process termination. So that's what that is. So 4688 is process creation. Do you also monitor process termination, or that really not? You don't really care about that?
I don't. I'm more concerned, did the process start? Not to say that termination is not bad either, but a lot of times, I get on the system and it's like, hey, this clicker possibly did it. Well, let's go look at the event ID. And if we have some other journaling of sorts, do we have it there? Or this thing is bad, where has it executed at? Well, let's pull our 4688 event IDs, and then let's look from that perspective. I haven't had a use case where termination has come in, not to say that it won't.
Well, I enable it in my environment, but we use it to time like logins. And so we need to know when it started and when it ended, so we can figure out how long the login process happened. So we enable it. So I have that data, so it's kind of interesting that I could use it for other purposes.
That's good. That's a great use case, actually. Yeah. I hadn't thought about it like that. That's pretty cool.
All right, I think Nando has charged himself up a little bit. He's ready to go. So let's let him fire off, so you guys can complain about too much information coming at you again. That's what's in the chat. Just so you know, it's a bunch of OMG. I stopped taking notes. I'm just gonna wait for the recording.
Oh man. Okay. I will pause after each one.
No, I mean, it's not bad. Everybody's loving the content, so we're super appreciative.
Yeah. Well, I said from the beginning, definitely passionate, and there's so many things to get in. So definitely trying to give you guys a lot in a little bit of time, if you will. But,
one of the first guys to really engage with PowerShell on the security side. So this is absolutely awesome. Most people live in Python, it seems.
Yeah, absolutely. Okay, so as we pick back up, fail to ban. If you're managing a Unix-based server or system, Unix, if you will, and it's publicly facing, I don't have to tell you that people are trying to brute force it every second of the day. And if that's news to you, that people are trying to brute force your publicly facing server or system every second of the day, I'm sorry to be the bearer of bad news. But those logs are very interesting. You can tell when it's automated, and you can kind of tell when somebody's sitting at the keyboard of sorts, but you probably don't want people trying to log into your server at their own free will for as long as they want to. You probably want to be able to identify when such things are happening, and then have some type of automated response in place, so you can then be a little bit more rest assured. Well, from a Linux or Unix perspective, there's an open source program called Fail to Ban, and it works well, and it does exactly what it says, right? So you can pre-configure a number of times in which a failed logon happens, whether it's SSH or actually interactive through the actual GUI, if you will. And then after that threshold is met, it will automatically block all communication from that IP for a predetermined period of time. Maybe you want to block people who have logged on or tried to authenticate to the machine 5 times incorrectly, and you want to block them for 2 minutes. Maybe you want to block them for 1 month, 9 years, whatever, right? But you surely don't want people trying to log into that machine every second of the day with no recourse. Well, fast forward a little bit, and we're dealing with Windows, and we have some public-facing Windows type servers and systems, and guess what? People are doing the same thing on those machines as they do on Unix machines. Go figure. Well, I wanted to be able to utilize fail to ban on Windows, but it's not for Windows. There's a couple of instances where people tried to port it over to Windows, but largely they didn't do what I needed them to do. So guess what? We took the PowerShell and just made our own. So yes, we can configure our own threshold. We can set the ban timeout, set it some auto remove, if you will. And then we're going to commit the IPs that we block to the event log. Because largely speaking, events in the event log are not just staying there, right? Because somebody of red team descent, if you will, could start to wipe their tracks. You want to be able to move those event logs offline somewhere else. Maybe it's a scene. In another talk, I talk about sending event logs to Slack. right? Call that the poor man's log aggregation server. You're not going to do them all, but things that you really care about. But nonetheless, that information also goes into a database in which we can hook up to a front end or do something else with. And then when you're in a bind, you can essentially remove all those IPs in one stroke, as opposed to removing them one at a time. And really, an orchestration or illustration is something like this. We got the guy on the left, we got the guy on the right. The guy on the left is malicious, the guy on the right is a good guy. The guy on the left is trying to log on as admin with the password of 123. He continues with admin and a subsequent number of other passwords. And finally, after the 6th time or so, he is successful. In some cases, this is unbeknownst to the person who actually owns the server. And if they would have put something in place, they could have prevented that from happening. So with something like invoke failed to ban, we would have set a measure of, let's say, 3. And after that person had 3 failed authentication attempts, we would have prevented any communication from that person. Well, you may be saying, well, let's say they're using admin 3, and admin 3 doesn't exist. That's just going to be a failed logon in your event log. No harm, no foul. If admin exists and they're trying to log on as admin, they may actually lock that account. And then you might be saying, well, they can't get in anyway because they locked the account. And then I, the admin, is tipped to it, and I'm just going to unlock it or whatever the case. We want to prevent this person from having any communication with us. And if they're the run of the night, I'm just trying to brute force whatever's out there, they're probably going to move on to the next server. Actually, there's a pretty high chance of sort. And if you block them for a substantial period of time, then you're no longer a threat. They're no longer a threat to you, if you will. So let's demo this and actually go through this. All right, so the minute we run it, we essentially have the ability to start monitoring carte blanche, and that's the one we're going to use. We can list the IPs in their status. Hey, we were blocking IP 1234, and it's been blocked since this time frame, or what have you. We can list all our whitelisted IPs, or if we're in a bind where we just messed up, right, we can just unblock all the IPs in one keystroke. So we're going to do number 1. And when we do that, it's going to take all the IPs that are assigned to any NIC of my system and add that to my whitelist. If there's other ones that I want to add, I have the ability to do that now. In this case, I'm going to say 2. No, I don't want to add any more to my whitelist. And then I get a list of those IPs that are being added. Now, I have this set up rather aggressively where it's something like 4 failed authentication attempts in 30 seconds of sorts. If I'm running this in production, I'm definitely not running it this aggressive, but for the purpose of this talk, again, it's going to be rather aggressive. And I have it spitting back out to the screen so we can see it. So we see that it was actually running. I'm going to come over here and I'm going to try to authenticate to this machine a couple of times. And we're going to fail, right? And here in a second, we're going to see it kick in. It's cool. It kicked in. It's going to add this firewall rule. And we see it there. We also seen it that it's committed to the event log. And I just gave it an event ID of 1337. And then when I come over, I see that I can no longer communicate with that machine. That's going to time out. Once my jail time has surpassed, it's going to relinquish that. And I think I have it blocked for like 20 to 30 seconds, and we'll see when it's no longer being blocked. And it'll tell us and it will remove that rule, and we'll be able to authenticate or play with this machine again. All right, so
Fernando, Jason had a question asking, is it blocking all protocols or just the protocol that it was failing on?
All protocols. All protocols. So good question.
So it's an IP-based block?
Yes. Yep. So it was blocking based upon IP. It's no longer blocking I have it committed to my event log. The rule is no longer there. And now I can communicate with that system again.
But I think one of the magics is that this is PowerShell. So you could basically, fork it from there, and you could add a little code here to say, hey, just do a particular port you want. So because you're just adding a firewall rule that's across all ports, but you can say across, you're blocking the IP as opposed to then the port, right?
And
Yeah.
in
Yeah,
a typical, in a typical enterprise environment, what rights are the end users going to need to be able to do that functionality? Are they going to be able to create firewall rules, or is that going to be restricted based on enterprise GPOs?
Yeah, I think that's going to be environment dependent. But my use case and everybody's use case is going to be different. My use case wasn't built upon a true enterprise environment because I don't assess in my enterprise that somebody is doing this form of lateral movement where they're attacking another machine. I would already prevent lateral communication of sorts. This is more for that system that's alone and unafraid, that's publicly facing out on the interweb somewhere of sorts. That was the use case in which I built this, and I haven't tested it from an enterprise perspective, but I could see where it could possibly work.
Nando, wouldn't that system be behind a load balancer in that scenario, or can this actually look at like cookies and whatnot?
In its current stance, it does not look at cookies. It's purely IP based. Not in this talk. I also wrote a packet capture in PowerShell, so we could actually dive a little bit deeper into the actual traffic itself. To your point, whether it would be behind a load balancer or not, I think that's network dependent, right? Because every environment's going to run things a little bit different.
Yeah, just in that situation, you're always going to see the same IP is kind of what I was getting at, unless you don't have SourceNet turned on.
Yeah, I think depending to his point is that it'd be unique to your environment and what you pass across that load balancer.
Yeah, absolutely. Good questions. I'm interested to see how you would use it in your environment, or maybe it's not fitting for it of sorts. But I think combining the packet capture with something like this, you can get a little bit more granular if you're behind a load balancer, or maybe it just doesn't suffice there. Other questions or comments? Okay, awesome. So we talked about a subset of blue team type stuff. We'll talk about a couple of things from a red team perspective, right? Again, a couple of things from a lot of things that we could actually do from a red team perspective. Well, fileless malware is the name of the game these days, right? If I can put code on your box that provides some type of malicious intent without putting a binary there, I'm going to absolutely do it, and I think most people would agree. So how do we get to that point? Well, we take that binary, and then we would convert it to bytes, a string of bytes, and then we might base 64 it. And once we have it in that base 64 code, we can then store it somewhere on your system, and as we need it, we could retrieve it, and then we could just reverse that process. Some people would say, well, I don't want to base 64, I want to go from bytes to hex. I say it's like a Reese's Pieces where you could do it however makes sense for you based upon the environment. Or if people get to a point or people have the next gen EDR where they start to identify this in an automated fashion, maybe you go data, bytes, base 64 to hash to bytes to base 64, right? So you're just extending that. Recognizing though, when you get ready to use it, you're gonna have to reverse that whole process before you get to that point. So some places that we would look to store this code, well, it could be the registry, because no admin out there knows every registry key or value, right? I'm knock on wood, but I don't know any that do. Active Directory, and that's kind of one of the examples we'll show as well. We could put it in event logs, where we're writing to the event log, and then we go read that event log and then take the data from it and actually convert it and then run it. The bad thing about the event log is we stand the chance of it aging out or rolling out. So we may want to look to use one that doesn't necessarily get data. So our stuff has a good chance of staying there much more longer. We can use alternate data streams, and when I tell you this is an old technique to just hide stuff in alternate data streams, it still works. It's like a trend from the 80s that's just continuously coming back. We got group policy objects as well. There's an ability for us to put a description in group policy objects. That description largely isn't used. So we can put data in there, put enough spaces in there where we're pushing our data off the screen, and then you have to actually interact with the object of sorts to be able to see that full data. And I'll take my chances, depending on the network and what I know about that admin, that they won't be able to see that or won't even interact with it. So utilizing something like Active Directory, we already recognize is going to be based upon objects, users, computers, and groups. And from an enterprise perspective, this is going to be great. On the right, we have the GUI aspect of it, and we largely have about 50 or so properties that are available. There's a number of other properties that are not visible by default, and we'd be able to see those in Attribute Editor. Again, I would have done some reconnaissance on this network in the admins to know if this is the right technique for me to use, or should I use something a little bit more different. We also recognize with the Active Directory module that we can query AD. Now, the regular domain user has the ability to query AD. Yes.
Can I add to your conversation?
Absolutely.
There's a GitHub release from about February that identifies how you can base 64 encode from a QA environment that allows to go to prod, and you can exfiltrate data, say like a telephone. If you are allowed the ability to write to like a telephone attribute in AD, because it's an everyone attribute. It really goes along the lines of what you're talking about. That you could base 64 encode and then take it back out and exfiltrate. I think it goes a long way.
Yeah, absolutely. And telephone number is a great field. When we get to the point of really talking about what we're trying to exfil or store, we get hemmed up on size limitations, right? So some of these properties only allow us to put 15, 20 characters. Like phone number is not going to allow me to put 500 characters in there. So depending on what it is that I'm trying to store, I may want to look for something that allows me to do a little bit more. Now, admins, and I gotta take my chances here and also understand the admin. Would an admin, when scrolling through, looking at objects, notice that the telephone number had some random text in there? He probably wouldn't know it was base 64, but would he notice it? Well, again, I think that depends on your environment. Where I look to go is something like the division property, maybe employee ID, employee number, because those are not shown by default when I'm just looking at that object from a GUI perspective. I'd have to look in Attribute Editor specifically for those things to be able to see it. Hence the division property, what I'm showing there. So even if an admin, when Attribute Editor started scrolling through for whatever reason on a particular property or particular object rather, and started to see stuff that was unfamiliar to him and started to interact with it, I could go in there and add in, 40, 50, whatever many spaces it is, and essentially push my code off the screen from the view that we see. That would then require the admin to think something is going on or purposefully want to interact with it. And then the minute they double click it, they'll see those spaces, but then they'll see my code after it. Again, right now, there's like 40 characters on the screen of the base 64, but it's not the whole thing. So I could prepend my base 64 with 40 spaces to essentially push it off the screen. This is making it a little bit more stealthier, already considering what type of administrator that I'm working with. And in some cases, man, I'll tell you, whoever just mentioned about the telephone, I might just put it right there in the telephone property because the admin, although he may feel like he's a top tier, doesn't see it or has not seen it. If I got a guy that's a little bit more stealthy, right, like some of you guys on here, I might try to go a little bit deeper and I got to pull out some other tactics of sorts. But nonetheless, when I go to interact with it, I wouldn't do it from a GUI perspective. I'd actually utilize PowerShell read that property, and then store it in a variable of sorts, do my reversal to actually interact with it if it's a binary, or I would just send it out through a WebSocket of sorts, coming back to wherever I need it to go. So from Active Directory, we have that. We can do the same thing with the registry. I'm right here nearly at the top of HKLM under software. Within the 7-zip key, I'm created two things. One of them, actually not here, but here under software, I created a value called updater32, right? It may sound legit, it may not sound legit. And in there, I got base64 code sitting there. Again, the registry is deep, and I wouldn't go one level deep in HKLM. I would go much deeper, and I probably wouldn't just store the code just like I did. Instead, I would prepend it with those spaces that I talked about. And additional to that, in the registry, we noticed that the default value has a value data of value not set. So I also started mine with value not set and then pushed it off 160 spaces before I then put in my actual base 64. And if you notice at the end of that line, I got 3 dots, right? So insinuating there's more to what I just see there. So an admin 1 would have to find my key with this value, and then he would too have to double click on it to interact with it. I'll take my chances of sorts, right? Now, this is a place where I start to store data for me to exfil. Maybe this is a rat or an implant that I then have on some pre-designated time frame where it goes to read this value, executes it, and then that rat, that malware, if you will, creates communication back to my server and then brings the value back as far as the next instruction of sorts. But notice, this isn't a running process that's just sitting there. This is going to be raw code of sorts, right? Now, with PowerShell, depending on the version, we start to get into some command line arguments of sorts that we can get after. We got some other logging in there. We got people who are still utilizing V2, or they've upgraded and they still have V2 there, so people downgrade to version 2, right? There's a number of things that we can do. And really when we say, well, when do we use this versus the next? It all depends on the environment. As I go to put in a sync, I have my toolkit, but really I don't know exactly what I need until I see what type of thing that I have to remove or not remove. So I'll pause there so we can discuss foulless malware a little bit with PowerShell.
So I got an interesting sort of point or question for you. So, you know, I'm the admin. I'm the guy who's supposed to try to defend the Mensis, and I just feel powerless. I feel like I would never even know where to begin to look at that stuff, right? So I see the techniques that you use, and I kind of feel that you're in the point now where this is stuff that people are not going to detect on their own. I mean, an admin may stumble across this when he's going to look, but if you go back to the other side of the fence from a blue team or a tool, are there tools designed to pick up those kinds of techniques that you just used?
Yeah, there's different tools out there that could highlight it, right? If you have a good EDR, endpoint cybersecurity solution, you possibly could configure it to monitor for registry key creation. Maybe that'll be too loud for you. You're gonna have to tune it. Maybe you could then configure or utilize event logs of sorts, because it's still a PowerShell process that's being called upon. It's just I'm feeding it that data, and it's going to be a command line argument. So when we look at PowerShell v5 and newer, although it's obfuscated now, every portion of the deobfuscation to the raw, whatever the command is going to be caught in the PowerShell log with version 5. But guess what? I don't want to say guess what. A good red team has the ability to wipe event logs. And we're not just talking where they wipe the whole PowerShell log. We're talking the ability to go in there and wipe specific logs themselves. Entry number 19, entry 20, right? And on my GitHub, I have a tool that I wrote actually in PowerShell called invoke ghost log that allows me to go in there and do that utilizing PowerShell. So what I'm really trying to say here is, from a defense perspective, it's tough. right? And I face it every day. But defense is really won based upon defense in depth, right? So maybe I see somebody coming in from our border firewall or what have you. I got something that's monitoring there. We got a firewall or some type of IDS. It gets to a point where it gets to an endpoint, and then we have a number of things that are happening there. And really, I think every organization needs to have somebody or some element proactively looking. There's been a number of times I've been in somebody else's machine from a red team perspective, right? I got authorization. And the admins just don't know we're there, right? Imagine that feeling where you're like, yep, my machine's running well. I got no logs or whatever, and all is well. Meanwhile, we're there, right? And we're just sitting there. So you have to have somebody proactively looking, always assuming that you're breached. A good red team, you're not going to see them, right? But every time we have something that is a convenient measure for an organization, security starts to go down a little bit. And with COVID and everything else, and people are starting to telework a little bit more, man, there's some people whose organizations are not necessarily built for that, and they had to, in an emergency fashion, transition over to telework. Well, did they really test out these services that they're really utilizing? Do they have monitoring in place where they could understand that people are actually bypassing security or they are being targeted? Are they using some form of multi-factor authentication? Are they even looking at the logs where Mike usually logs on 9 to 5 Eastern, but now all of a sudden we got him logging on weird times of the night, right? Understanding that persona of sorts. Hopefully that was helpful. I went off on a tangent a little bit.
No, it is. I just realized I can only book you once a year. I need a year to recover, so I feel better about myself.
No, it's all good, right? and really, the more we talk about red team tactics, the more you get exposure and experience. Because frankly, how do we defend something if we don't even know what's in the realm of capable, right? So we start to see things that could be done. Now, unfortunately, if we walk away and say, I'm going to specifically monitor for this, again, every environment's going to be different. As a red teamer, you're going to have a different subset of things that you can pull out your bag of sorts. But who knows? You might catch somebody doing this and you feel pretty good about yourself. Absolutely. Other questions or comments? Okay, so we can also do port scanning with PowerShell as well. I don't necessarily need Nmap, or I don't necessarily need NCAT or NetCat. I can utilize PowerShell. I got access to this box. I now want to see what's in the realm of possible in the sense of what else can I touch in this subnet. Maybe I'll do something like NL test binary resident on the Windows box so I can understand domain trust. Maybe I'll start to poke around, look at ARC tables and everything else. But more importantly, I want to be able to port scan a little bit and see what else is open in my reach so I can then look at what exploits are available and do some weapons pairing and start to do some exploitation of sorts. So we utilize this in the reconnaissance phase. This is going to help us understand what services are running on a system. And if we can understand that, we can start to profile the system, but also look to get something publicly available for an exploit and leverage it. I wouldn't necessarily worry about 0 days as much because there's things that have been out for years that organizations are still susceptible to. Right, so we can do this port scanning utilizing a .NET class. We can also utilize a commandlet from a V5 perspective. Now, this commandlet does some pinging with it, so it's a little bit slower. It's going to do a full connect scan if we were talking about NetCat, but it also does an auto close. So it opens it, does the scan, auto close. With the .NET framework, we utilize a full scan, but it doesn't auto close. So when we open it, to do the scanning, we also need to go in there and close it. We could also do some banner grabbing. It's not enough for me to scan a machine and see that port 80 is open. I want to see what's the listening service so I can then deeper or more enriched profile the system. This could help me identify the operating system, what type of service, what type of version is running, right? And not only does it help the red team because they're in the reconnaissance phase, if the blue team would actually do this from time to time, they could identify not only rogue systems, but misconfigurations. Hey, I didn't know we had this running, right? There was a time where an entity had a VTC that was being infiltrated. Actually, there was an actor already on that system. So when I called the organization about it and told them, they're like, hey, this IP isn't a VTC, it's a router. And I'm like, no, it's a VTC. Fast forward, and of course it's a VTC, and I'm telling them that the person is SSHing in. The admin's like, there's no SSH on here. Guess what's on there? SSH. But if we're doing some proactive analysis to be like, hey, SSH is open on this thing. I did not know that. Well, let's go ahead and fix that so somebody else isn't taking advantage of it. Let's walk through both of these things so we can see this in action. All right, so I'm going to come through and we're going to do a port scan. I'm going to do it on .200 and I'm going to specify 2280.135.443.445, right? I'm not going to do all 65,000 and odd ports. I'm going to do something very targeted, enough to fly under the radar, if you will. And what I get back is essentially TCP test succeeded. That's going to mean that the port is open. If it's false, that signifies that it's closed. Okay, awesome. I now see that this system has 4 ports open, but I'm not necessarily in the position to figure out if it's Linux or Windows or what have you. So I'm going to do a couple of other things in which we'll look to do that. In this case, we'll just try to do a banner grab. We may get some information back, we may not. I could also do some small things like actual pinging. So we see that with our TTL, right? We see Windows traditionally has a TTL of 128, and we can start to say that that's possibly a Windows box. But I got a banner back on a couple of things, one being SSH. So we see flow SSH, bitbuys SSH server, win SSHD. That screams to me that it's a Windows box, but I'm not the smartest person in the world, so I'll transition over to Google and I'll look that up. That'll help me confirm that this is actually a Windows box, or maybe it could be a Linux box as well, that maybe it is ported over. If that's not enough, I look at what's listening on port 80 and it's Microsoft IIS, and I see the version. Now I'm at a point where I can confirm that this is a Windows box. I see some software that's running that's accessible to me, and then I start to look at what exploits are out there publicly that I can then weaponize, i.e. utilize for me to exploit this machine, or maybe it's something that I can change around a little bit to then exploit the machine. There may be some script kiddie stuff already available in the sense of Metasploit of sorts, right? But we went from essentially fingerprinting the machine to information gathering fairly quick. All right, so I'll pause there for questions, comments. Okay, nothing heard. So if you're used to Python, you probably are aware of, I'm sorry, go ahead. Okay, nothing heard. You probably heard of the simple HTTP server, right? Where we can stand up a Python web server very quickly, very hasty to serve data. Well, we can do the same thing in PowerShell. And we're going to do it from an HTTP perspective, but we could do it as HTTPS, utilizing something like Let's Encrypt or our own certificate somewhere, or we can do some self-signed certificate. Now, when we're doing a well-known port, we have to have admin rights. But if we're doing it a high ephemeral port, we don't have to have admin rights, so that's good. We can stand it up, tear it down as needed, and it will serve content from our desktop. We can configure that to serve content from wherever we need. And where we would use this is typically post-exploitation. I've already got on the box. I've done a survey of the machine, i.e. I've gone around and made sure that there's no other malicious actor on this system, and there's no type of antivirus or defensive tool on here that would then illuminate the thing that I'm about to bring afterwards. It's almost like breaking in somewhere and then doing a reconnaissance and then saying, okay, boys, the coast is clear, come on in. So from this perspective, we'll look to bring on additional malware payloads or additional aspects of our toolkit. let's go ahead and walk through this so we can see this in action. All right, so I've actually have it running. I meant to stop it beforehand, right? I wanted to make sure the demo gods didn't get me, but I'm running this globally, and I'm gonna run it and bind port 9000. And it's very hasty in the sense that we're talking like 85 or so lines, and without formatting, we can condense this a lot more. This is running as a job, so I get my my terminal back, if you will. So we'll come over to my other machine, and we're gonna navigate out to that system on port 9000, and we'll have what's on the desktop being hosted or accessible to us. And we can come down and we can start to download whatever we need. Maybe I'm gonna come back and grab Netcat. Maybe we'll come down and grab whatever this pick is or what have you. Well, my AV detected it, right? That's probably good. All right, let's come down and grab this one. My AV didn't trigger on that one, right? And this is the good thing about us writing in PowerShell. What did it trigger on? Because if it's raw code, I can go back in there and alter it. In this case, Netcat is heavily signatured and good on the AV for finding it. But once I'm done with this, I can come back in here and I can essentially stop this job, right? And essentially tear down that server, right? Making it inaccessible. Now, I've just stood up a very quick HTTP server so I can access data. When I'm done, I turn it off. And we'll find that malware authors do this, where they have their malware on a system scheduled to beacon back, i.e. create communication back to a home base or a C2 server on some predetermined schedule. So the malware author wouldn't keep that server running 24/7. They would just turn it on around the time in which they expect the system to call back, allow the system to call back, give it a new instruction, and then they would tear it down, right? They do that because if a DCO or defensive person finds it, they don't want them just out there trying to fingerprint or touch that server, right? They'll probably have some other authentication methods associated with it, but we see that we can stand up this web server for the purpose of red team activities very quickly. All right, and I'll pause there for questions and comments.
So somebody was asking about, you know, would you be able to see this traffic running on 9000? Like,
Absolutely.
or like, no, you'd be able to see it, but like, would other like SIMs and EDRs like be watching for like HTTP traffic over port 9000? Like,
And good question. And honestly speaking, on my C2 server, I wouldn't do it on 9000. I would do it on something a little bit more well-known like 80 or 443, and I probably would encrypt it, right, if I had the time and opportunity. The real question is, do client workstations, would it look suspicious if client workstations were navigating using web on port 9000? And I think, again, that's going to be environment, you know, specific, but the safe bet is to host that malicious server on a well-known port like 80 or 443, and then absolutely no, it would not look suspicious because it looks like web traffic. And your client reaching out to the web, well, that's what clients do. But if you're monitoring for traffic, yes, you'd see that client talking to a server on 9000. Absolutely.
Sure.
Okay, so moving on, this brings us to the summary, right? So I don't have to tell you PowerShell is powerful, right? Specifically used for sysadmins, but we can do so much more with it, and people are doing so much more with it. From a blue team perspective, we could build an EDR out of it. We could use it for incident response, doing some IOCs. We can do some disk and memory forensics with it. From a red team perspective, we can do things like malware stagers, fileless malware, if you will. We can create implants, kind of like what we were just doing, where we have the endpoint communicate with our server. We can inject into memory, port scanning, and it just kind of continues on. So much we can do with it. Now, if you're still wanting more of PowerShell, which you're all PowerShellers, which I love, here's something else for you. Under the wire, So myself and 2 other people developed this in 2015. We have 75 challenges on here. They're linear in nature, so you have to do one to get to the next. 5 different games, and to date, we got about 140,000 unique people who have played from 84 countries. We make no money off of this, and we sit off in Slack if somebody ever needs assistance. And when we look at using this, it may be something like this, right? So you're able to go to the site underthewire.tech. You'll go to War Games. We'll give you a little bit about them. There's 5 games here. We'll start off with Century because that's going to be the first one. And essentially, it's telling you to register on our Slack channel because that's where we put the creds, but that's also where we want you to come for help. The first thing you're going to do is you're going to SSH into our server, right? And from there, you're good to go. Once you've SSH'd in there, you're good to go. So I'm going to come in and I'm going to do SSH Century 1. Right, and I know when I'm in there because my path is going to change, right? So I'm in there under the wire PowerShell training for the people. I finished this challenge. So now I'm going to move on to the next one. And here it's telling me the password for Century 2 is the build version of this instance of PowerShell installed on the system. I get some notes associated with it. So each one of the users is a new level. I'm logged on as the user Century 1, but that's really level 1. When I get the challenge password or finish the challenge here, whatever that challenge answer is becomes the password for Century 2. I'll do whatever the challenge is there. When I get that answer, that becomes the password for Century 3, and you just continue on, right? So we're going to get the build version here. Build version, I'm going to come in and I'm going to do PS version table. Right, and I have that build version. Now, if I'm a little unclear if that is actually the right answer, I'm not going to come in and close out that window. I'm going to just save the other one open real quick, and we'll go in here. Right, and we're going to copy this build version. And then we're going to log in. And I know I'm good because my path has changed. I'm logged on to Century 2. I'm going to terminate. And you can play this from any system that has a SSH client and internet access. So now that I'm logged on to Century 2, I'll just move on, right? And it continues on and on and on until I get to the end. And then I'd log into the next game. So that's under the wire. This is more focused on getting comfortable with PowerShell of sorts and less about defense and offense, getting comfortable. Now, the bad thing is, and I'll acknowledge that, is that it's linear in nature. So you're going to have to complete one to get to the next. If you're beyond that, we also have Posh Hunter. So I developed Posh Hunter in 2017, over 90 interactive challenges, non-linear in nature, blue and red team focused, and guess what? You can jump on and do whatever it is you need to do. You're going to end up downloading a virtual machine that already has the artifacts in there. I do a number of customizations. One of them is I take away the GUI, if you will. So the minute you log on, it's almost like you're on a Windows Server core where all I give you is a terminal, if you will. So you're going to get the ISC, you're going to get the PowerShell console. But we'll log into the web UI so you can see this site. All right, so you come out to poshhunter.com. You would register, we'd validate your email of sorts, and then you'd be able to log in. Once you're logged in, we got categories like encryption, cipher, file system, registry, logs, tasks, enterprise services, DNS, data manipulation, and question and answer, right? Maybe you want to do some question and answer, kind of get your juices flowing and get out the gate, but you'll notice there's a number on each one of them, and that's based upon how difficult it is. So we see something like this, rogue web server, and really each one of these puts you in a scenario of sorts of you being either a red team person or a blue team person. So in this case, you're a red team person, right? You look over some notes from another penetration tester on your team. They mentioned not seeing some information, blah, blah, blah. And then you have a task. Once you get that answer, you're going to put that in. You're going to click submit. If it's green, you guessed it, you got it right. If it's red, you guessed it, you got it wrong. Now, if you want, you could actually request for a hint and you'd lose 5 points of sorts off of that. So 90 or so challenges, non-linear in nature, and you'd be good to go. So some of you who are like, man, I don't really do some of this DCO stuff, but guess what? You're like stand-up sysadmins. So surely you can come in here and, I don't know, get the total number of users in Active Directory, right? Maybe you can come in here and you can get the total GPOs. Maybe you can even come in here and say, hey, who has the description of CTO within Active Directory? And guess what? You'll start to notice you're a lot further ahead than what you think. Recall when we talked about the landscape and there was a number of duplications and tripling of sorts. And this becomes one of them. Red team guys looking to understand who's the CTO so he can try to target him. Blue team guy, maybe trying to see if somebody is targeting him. The sysadmin is trying to just make sure the person's account isn't locked or his attributes are good to go or what have you, right? So PowerShell allows us to get that granularity to kind of get after some of those blue and red team tactics. And with that, we're finally at the end. Sometime tonight or in the morning, I'm going to post these slides at this link where you'll get it. There's my GitHub. If you want to continue to communicate via Twitter, you have it here. And I would tell you, you want to talk about PowerShell, I'm game. You want to talk about security, I'm game. If you want to talk about gardening, that's not my cup of tea, right? So I look forward to possibly meeting every one of you guys one day and definitely interacting with you more. To the people who put on this, again, I really, really appreciate it. A whole group dedicated to PowerShell. This is amazing. I hope you continue to do what you guys are doing. And I heard you're booked all the way out to March. So if I want to come back, I need to go ahead and get on there. And my earliest is March. So with that, I'm going to go ahead and pause. And Mike and team, I pass it back over to you.
Hey, Nando, before you go, could you talked a little bit about ghost file or ghost log write. Do you have a similar function for resetting last attributes on a file? So you could hide your tracks by changing date time modified, last accessed, etc.
You're muted. Nando, you're muted.
Nando, you're muted.
Yeah, that's an important factor. Excuse me. I don't. However, that property is writable. So we could absolutely write to the last modified time or last UTC time or last whatever time, right? So we can actually do what's called time stumping in that fashion. So yeah, we can do that fairly quick and easy. Absolutely.
And
Yeah,
so
my comment to Clem is that's actually, there's not really a script for that. It's just actually you write directly to the attribute. We do that pretty frequently in the client side stuff. So like moving files around and stuff like that. Sometimes if you move it from folder, depending upon who you move from across networks, you may rewrite the file and how you move or copy. And so if you need the file to be exactly the same, ICALs or IACLs, changes some of the attributes, but it's just straight up in PowerShell. You just get the file and you write it back out. So
Yeah,
it's an easy thing to do.
I'm just trying to think of things that could possibly be added as forks to this project. I've been out looking at GitHub.
Oh, yeah. Oh, yeah. Add to your thing. Well, I think it's a great idea.
Yeah, absolutely. Now, if we're getting to a point where it's like, hey, are we truly time stomping, and is this a true method in which the red team is good? My argument is no. What that does allow them to do is certainly change it as we see it on disk. But if we get to a point where we're doing disk analysis, we'll absolutely be able to tell that that property was changed of sorts, right? But we need to be triggered to say, this box is suspicious enough, and let's go ahead and grab stuff like the USN Journal, MFT specifically, to be able to go deep dive on it, right? And in an environment of 4,000 to 5,000, 15,000 machines, this is where the adversary or a red team person really wins out, because the depth and scope of machines that one would have to defend is so deep that unless somebody is triggered to go look there, they might not ever notice it, right? Think about the people who are serial killers in neighborhoods. And you're like, I lived next to John Bob for 40 years and never knew it because something had to trigger the police or law enforcement to go look into John Bob. And that's when they realized that he has bodies in the basement.
So, first off, thank you so much for spending time with us tonight. And I know, it's amazing. And the comments, if you haven't had a chance to see them, are fantastic. A few programming notes. So, Fernando, we'd like to have Jeremy Brown, who's one of the gentlemen that runs our group, reach out to you and take your stuff and also put it on our GitHub repo so people have a central spot. So we'll do that. There was a question that kind of beat me to something I wanted to ask you. Someone asked, do you blog? And I was going to ask an iteration of that. So I don't think you blog, correct? Like regular article writing. You're muted.
Yeah, so,
Okay.
so cyberfibers.com is actually my blog. I think I've written one article. Actually, I think I've written one article this year, right? So I'm not as active on there as I used to be, but I like to think I'm somewhat active in the Twitter sphere, much more than the actual blog of sorts right now, and that may change in the future. Right now, while we're dealing with COVID, forensics and malware analysis is actually peaked. Right. So stress that work a little bit.
So, but on a separate note, for the East Coast people, Fernando is a frequent speaker at a lot of the conferences when they ramp back up, and I'm sure a lot of the conferences are virtual now. But I mean, I've followed him and I see him constantly doing stuff. Georgia, back up to Baltimore, I've seen you, and everywhere in between. So there's opportunities to come see his talks and get more knowledge. Obviously, his website. What I wanted to ask you a little bit related to this, someone said, do you blog? But I wanted to know, like, there's a lot of information out there to grab. Do you have any recommended sources of blogs to follow or people that would be good sources of information for people to sort of follow and read and learn from?
Yeah, so I would be remiss if I didn't mention the Godfather, Lee Holmes, right? So if you're not following Lee Holmes, you definitely want to do that. There's other folks that are just super duper awesome in PowerShell. Mike, you do great stuff. I know you probably humbly say that you're not great, right? And the same thing with your battle buddy of sorts. Jeff Hicks is super good. But when we start talking about from a defense or a cyber perspective, we got folks like Matt Greiber, who's super duper good. We got folks like, gosh, I don't even know his real name. It's like Ben, but he's got some handle of like Enigma something, right?
These are Twitter people?
Yeah, these are Twitter people. Like Matt Greiber is his real name, right? He's the guy who actually wrote PowerSploit, a full-fledged Metasploit-like capability in PowerShell, right? Highly signaturable of sorts. But the other guy, the Enigma person I was talking about, he does a lot of memory injection of sorts. There's another guy, I don't remember his name, but he wrote actually what's called Power Forensics. So a whole forensic suite in PowerShell of sorts. So when we look at parsing the MFT by itself, he's actually written a module. So if you're used to like Encase, think of his modules almost like in scripts, if you will, right? Encase paid for, his module not paid for, but I tell you, it does a lot of greatness, if you will. Yeah. So there's no shortage of people who are actively doing it.
So recommendation to the people who are still on the call tonight, or if you're watching this at home, follow wired_pulse, and maybe we can ask Fernando to shout out some of the people that he recommends, and then you guys will get the names from when he shouts them out in the upcoming days or weeks, and we can do that. So why don't we wrap here? So we need to say a big thank you to Fernando for presenting tonight. Absolutely fantastic information, crowd favorite. Chat was blowing up. Everybody loves your stuff, so we're super appreciative. And thank you again, everybody, for joining us, and we'll see you next time.